On my LinkedIn page, I posted a question that how can you determine path that target router or destination router is taking to route packet back to the source network, right? So 40% people voted for Traceroute, 58% extended Traceroute, and 2% hardly extended ping with regard route option. Let me explain question properly. So you have access of R1 only, you don't have access of R4. Network behind R1 is 10.0.0.0/8 and network behind R4 is 172.16.0.0. Right? To simulate the scenario, I have configured loopback interface on both the routers R1 and R4. Question is how you can determine which route or path R4 is taking to route packet back to 10.0.0.0 network, right? Whether R4 is taking like route via R2 or R3, and you don't have access of R4 router. You have access of only R1, right? So simply if I launch traceroute command like sourcing with 10.0.0.1 and destination 172.16.0.1, so whichever like path we see like in the output of traceroute command is from source to the destination, not necessarily the same route R4 you would be using. Now let me quickly show you. So if I launch and we have access of R1 only, okay, traceroute 172.16.0.1 source 10.0.0.1 is a standard traceroute command, right? So sourcing with 10.0.0.1, destination is 172.16.0.1, and I hope you all understand like how traceroute command works, right? TTL decrement and all that concept. So I don't want to explain like traceroute command because you understand that. So first, hope I can see 12.0.0.2 and next 24.0.0.4. Okay, means R1 is like taking route via R2. But what about R4? Whether R4 is taking the same path, same route to route back to packet to 10 network, or R4 is using different route. How we can determine that from R1? Even if we run the command show IP route to check the routing table of R1, so even that wouldn't help us. Okay, understood? So objective is to determine which path, which route R4 is taking for 10 network, right? From the R1 itself. So even if I simply if I ping IP 172.16.0.1 sourcing with what do you call it? Sourcing with 10.0.0.1, not of any use because ping command means just I'm sorry, like I typed wrong IP address. IP should have been 172.16.0.1. So if I ping 172.16.0.1 sourcing with loopback address, my loopback address 10.0.0.1. So just like 5 packets and 100% success rate, round trip timer, we can see here 16 ms, 20 ms is average, max time. That's all, right? What if we just type trace route, only trace route, okay, means extended trace route command, protocol IP, target IP 16.0.1, source IP 10.0.0.1, timeout, probe count, you can set here, maximum is 3, you can set it to 1, time to leave, maximum, minimum, port number, and even if I head down like R to record the route, number of hops 9, okay. So it's like extended trace route command. So extended trace route or extended trace route, extended ping, just type trace route, hit down enter. Same like with ping also. In ping even you will be asked like whether you want to be in extended mode, and once you enter in extended ping command mode, so you'll have whole bunch of options. I mean, you can set df bit like do not fragment bit, source ip address, dscp marking, destination ip address, right? Too many options in fact. So I can see here like the first record route is very similar like 12001, and with of course like option bytes and receive packet. And second hop after first 24004, 24004 you can see in the diagram, 24004 and 12002, same like going this way. All right, so it's extended trace route command not finished yet. So I can see like two hops, 12 and 24002. And since like three packets, so will be done like three times. In fact, here like we could have like set to that one only, right? Only one probe. So same output. And question was like uh, knowing like a determined path from the target or destination to the source, and from the source gateway, from the source router, right? So trace route, extended, just ping command, of course, will not help you out. What about the fourth option? Extended ping with record route. Extended ping is really very, very important command in Cisco routers. Even if just let me till the time is ticking. Okay, done. So even with extended ping command, you can determine interface MTU of neighbor router. Let's say you have access of Verma and you want to determine, you want to know interface MTU of R2, right? Maximum transmission unit. Maybe you want to set the same MTU to your router R1. Okay, so uh, there there are like a lot of methods, and like in BGP protocol, for example, the IP TCP path MTU discovery can be used. In case even if MTU not determined, then the lowest MTU is used there. Lowest MTU, 536 plus 20 plus 20 means 576 bytes total, including IP and TCP header in case of border gateway protocol. But what if we want to determine neighboring router interface MTU from here? So again, the same extended ping command will help you out, right? We can make use of do not fragment build. I'll explain later, not in this session, in fact, because I want to explain like this regard route option. So now still we haven't determined like path that R4 would be taking to route packet back to R1. So what if I just run the command ping, right? Because I want to get in like extended mode. I want to enter in extended ping. So just type ping protocol IP, target IP 172.16.0.1, repeat count. You can set the repeat count. Default is 5, datagram size 100 bytes. I'm okay with it, no problem whatsoever. What about time in second? That's again fine. Extended command, right? Type Y, yes, I want to use extended options. Source address 10001, okay. Type of service, so I don't want to play around like DSCP and IP precedence. DF bit, like do not fragment bit in IP header, no. Validate reply, data pattern, and see record route option. Like hit down R, record route or RR option. What it does basically, record route option. So whenever we use RR option or record route option, So what happens? Ping means like ICMP encapsulated inside IP, no TCP, no UDP, right? So IP header means like source IP, destination IP, TTL field, do not fragment bit, protocol number, identification, length, checksum, right? And there is another important field here, and that is IP option field. IP option field, right? In IP header. So when we enable record route option, RR option, so RR basically instructs router to record their IP addresses in a packet, and where that information is recorded in IP option field of your IP header. Inside IP header, there is a field IP option. So routes are recorded, means their IPs are recorded, right? But again, it is subjected to 9 hop limit. There is one limit, 9 hop limit, one of the limitation, and traditionally inconsistent support from routers, firewalls. Because let's say if you have any firewall in the middle of communication stream, and if you have enabled record route option, so most of the firewall, before like checking packet with security policy or other policies, first initially sanity check is performed, right? So layer 2, layer 3, layer 4 informations are extracted from the packet, layer 2, layer 3, layer 4, and like thoroughly examined. In fact, if everything is up to the mark, like consistent, or there is some inconsistency. For example, if protocol number like inside IP header is maybe different, and the upper layer protocol is different, or maybe same source and same destination IP address, again that is something not acceptable to the firewalls, because source and destination IP, they both cannot be same. What if the source IP address is any IP from multicast range, like maybe multicast address 224 to 239 range? That again something wrong with the packet, because source address can never be multicast address. Destination address can be multicast address, but not the source, right? So if source destination IP both are same, source IP address is multicast address, maybe some issue with the inconsistent information, protocol number is different and upper layer protocol is different, not like reflecting the same protocol, right? Or maybe port number is zero, or protocol number. So that means packet will never be inspected with security policy, dropped, right? And in some firewalls, like even IP spoofing or NT-IP spoofing is also enabled. Okay, so that means sanity check is done before inspecting traffic with security policy. So same with this record route option. So record route option means if like we like enable this record route option, that means we have instructed router to record their IP addresses in a packet, okay, in this IP option field. And if firewall in the middle of communication stream see that like IP or find any data in the IP option field, then dropped. So record route is, yes, first limitation is subjected to a 9 hop limit, and not very consistent support from routers, right? But let's see what output we get if we enable record route option. Number of hosts maximum 9. Yes, we know that. Sweep range not required. We do not want to use. Dear bit, of course, not used. And I hope you understand like what we are trying to find out. We are trying to find out like which path R4 is taking to route packet to 10 network from 172, right? And we do not have access of R4. because the easiest method would have been like launching Traceroute from R4 just to determine the path, in fact. But since we do not have access of R4, we want to determine from R1. From R1 perspective, we want to know. So that's the reason like why record route option is the only way to determine that. So you can see here like in this record route option, I can see like 12001 like local exit interface. So which one? 12001 means like first, and then 24002. 24002 went to this R2, and 172.16.0.1 34003, right? 34003, and then 13003 10001. Okay, 34, 13, and then 0. So 34 is this network segment, and 10 is obviously here, and 13 is here. Means R4 like took this path from R1 to R4, and from R4 perspective, if R4 has to route back to 10 network, then R4 would take this path, right? This way. Okay. Now let me show you, like, since it's a lab environment, you understand, we have just simulated the scenario. So obviously we have access of all the 4 routers. So now let me quickly show you routing table of R4. Show IP route. So R4 has route for 10 network via 34003. It's a static route. Other networks learned like via OSPF. What about R1? So R4 next hop is 34003. 34003 means R3. What about R1? So it's still like we like selected repeat count 5, in fact. So would have been like only one, but no worries. But you understand like here, right? So R4, if we will check the R1 routing table, then R1 is pointing to 12002, right? 12002 from here. So from R1 perspective, like 172.16.0.0.0 static route, next stop 12002. But R4 10 network, next stop is 34003. Good so far? Understood? So extended ping command in Cisco routers are really very useful, very important, right? This record route option sometimes like is really very helpful. Apart from that, even like the DF bit option you can use in extended ping command. Do not fragment bit. Do not fragment bit. Do not fragment bit. And what's that basically? So let's assume. Let me take these 2 routers for a moment, and quickly let me show you R4 R4 interface MTU. R4 interface is F0/1. MTU maybe 1480, right? So interface MTU 1480, and R3 interface MTU is 1500. So 1480 bytes, and here 1500 bytes, right? But now let's assume you don't have access of R4, you have access of R3 only. You want to determine interface MTU of R4, and if you are not familiar with MTU, then let me quickly explain you what is MTU. So MTU stands for maximum transmission unit, MTU, right? Means if interface MTU is 1500 bytes, that means maximum packet size can be 1500 bytes. But what if packet size exceeds MTU? If let us assume packet size is 1600 bytes. So packet size exceeds MTU. Then what happens? Packet is chopped off into small fragments. Fragmentation is done, and on the other end, fragments are reassembled, right? Reassembled. That's what fragmentation is. But generally in networking, we avoid fragmentation. And why we avoid fragmentation? Because fragmentation will cause like, in fact, may cause like some security risk. Okay. Plus, will increase CPU cycle, CPU utilization of both the devices. Sender like doing fragmentation, packet is chopped off into small fragments, and on the other hand, they are reassembled. So generally we avoid like fragmentation and all that. And best practice is to adjust MTU or maybe MSS accordingly, right? So and even like if you know about OSPF, then even OSPF, what OSPF does, if there is mismatch of MTU, then even never ship will never come up. Either we can run the command like with M2 ignore command, we have that option, or maybe we can set like our same M2 on both ends, right? There are two different methods. So, but point here is how we can determine interface M2. So, let's say if I launch ping command from R3, and if I say, let's say I want to ping this directly connected interface 34004, and if I send a packet of 1500 bytes and do not fragment bit is set, D of bit, right? Means in IP header field, there is D of bit, do not fragment bit. If D of bit is set, means enabled, that means router has been given instruction not to do fragmentation. Even if packet size exceeds MTU, but do not do fragmentation. So what router will do now? Router will not perform fragmentation. And what's the size here? 1500 bytes. So packet size exceeds MTU and router is not allowed to do fragmentation. So as a result, you will see your RTO, request timed out, or packet is not sent basically, right? So we can make use of DF bit to determine interface MQ of next hop device. And how we can do that? Simply we can use extended ping command from R3. We can do a ping sweep. Maybe we can send a packet ranging from 1450 to 1500, or maybe you can take a wide range like 1400 to 1500. This is what ping sweep is. And also you can enable DF bit. Means router will first send a packet of 1450 like bytes with the bit enabled. Then the next packet 1451, 1452, 1453, and so on. Now let's say you are continuously getting reply or response back from the R4, right? And then after some responses, you see like request timed out. So you understand like first packet means 1450, then 1451, 1452, and so on. Let me show you quickly that also. So from R3, I'm here on R3, and objective you understand. So if I ping 34004, size 1500 bytes, and D bit, so of course, and just DF bit is enabled, means packet size 1500 and fragmentation is not allowed. DF bit, no luck, right? What option we have? 34. Repeat count only one packet, right? One packet. Datagram size 1500. Timeout. Now I want to use extended command. Source address. I'll definitely use 34003 type of service, and yes. So set DF bit in IP header. Enable this, right? Yes. validate reply, and where is ping sweep? Yes. Now minimum size. So let's say I want to start with 1450 and maximum is 1500. So let me explain one more time. So what happens now? R3 and R4. Now R3 will send a first ICMP packet, ping packet, IP header, ICMP header, and of course tier bit is enabled, means fragmentation is not allowed, so R3 cannot do fragmentation, but the packet size is, the first packet size is 1450, right? And then 1451, 1452, 1453, 1454, and so on, right? So if we are getting responses from R4, so maybe the first one 1450, 1451, 2, 3, 4. So you can count like, and this way easily we can determine interface MTU. So head down, enter maximum sweep interval, and see here like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, and then after continuous RTO. So if you will count, then you will understand that next hop device interface MTU is 1480, because R3, whenever we will send a packet with size 1481 and dear bit is enabled, so obviously no response would be received from R4. Our phone is restricted not to do the fragmentation, and our 4 interface M2 is 1480. So up to 1480, yes, proper responses, and after that RTO. So either you can count like success, or maybe you can count like darts, so you will understand, right? Maybe this stats, in fact 31/51, 31 answered. So now you understand like 1450 started with 1450, and only 31 were uh, answered properly, and then after RTO means next hop device interface MTU is 1480, because 1481 no response. So extended ping command is really very powerful. So I hope you all understand like right answer, and I think only one out of 42 um, has given correct answer, because I can see here 2% only extended ping with record route option. Okay, trace route is something just um, like traces path from source to the destination. It's unicast routing, right? Unicast routing, source to the destination. So destination is not coming to the source. It's not multicast routing. It's unicast routing. All right. So I hope you understand like extended ping command in Cisco routers.